Next question I'd like to resolve when it comes to using discriminants is answering the question, which discriminant should we use? So we've got a number of options. First one I've just mentioned in the previous video when I said, if you're using a discriminant and you're wanting to find the critical values of an equation, we make that equal to 0. And the example I used, I said, let's say you've got an x squared plus a kx plus a 4, and that's equal to 0. We're wanting to find the range of values of what k could possibly be that would make that equation true. That's what we're doing. And we just did that before, and we found the possible range of values. Either we could say k was equal to a negative 4, or k was equal to a positive 4. And we do that by making the discriminant equal to 0. In this case, we populated our equation by saying that the coefficient of this one here is going to be a 1. So a is equal to 1. That's a 1. The coefficient of this x value here, this is x to the 2, its coefficient is a 1. X to the 1, its coefficient is a k. There's my k. So then b is going to be a k. And c is going to be the coefficient of x to the 0. It's x to the 0, which of course is 1. But our coefficient is 4. So c is equal to 4. Now, you go ahead, put all that into b squared minus 4ac, and you end up with a k value of negative 4 and positive 4. And if you want to see how that plays out, just watch the previous video. All right, let's have a look now at other possibilities. Now, another reason you'd want the discriminant to be 0 is, let's imagine you were looking at a situation where you were told you've got, let's say, a circle, or maybe a parabola, or maybe some sort of a cubic, and you were being told that there was a line that was a tangent to one of these things. For example, there is the line being a tangent to the circle. In other words, it's touching in one place. It does not cross over the line. It merely touches in one place that circle, that curve. In the same case, this one over here. Let's say it crosses over here like this, and it touches in one point. Doesn't matter where it crosses. It might have been further down here. What about this one over here? Let's say this one crosses, and I'll just make it. Oops, looks like it actually went over the line. But if it's touching in one place and it does not cross over the line, and that one kind of looks like it does a bit, but in that case, in order to find where the point of intersection was, you would take the coefficients of the equation, you would use the discriminant very much like what we had here, and you would say, let's go ahead and we're going to make the discriminant equal to 0. So in those cases, discriminant is 0. So let's just take an example of that. Let's say, for example, you've got, what would be a simple example? Let's say you've got the circle, yeah? We've got a circle, and let's say our circle, I'll make the circle look like this. So here's our circle, and we'll put it straight through the origin. Here's my origin, here's y, here's x, and let's say the equation of the circle is x squared plus y squared equals 4, yeah? And let's say I've got a line, and the line starts at, let's say that starts at negative 4. And I'm wanting to find out what are the possible places where this could touch that curve at one point. Of course, it can touch over here, but also touch, going through there as well, over, that was not very good, but it could touch over there as well. To find out what that would be, I would take my line, and my line is going to be y is equal to, I know the gradient, the intercept is going to be negative 4. I don't know the gradient though, so I would make it m and have an x here and say, right, let's manipulate that gradient until we find the point at which it touches a circle at one point. In other words, is a tangent. So what would we do? We would say, let's incorporate this here. There's my y value. I know what y is. Let's pop that straight into the equation here. So now we would say x squared plus y squared. Well, y is mx minus 4 all squared and is equal to 4. I would subtract 4 from both sides, make the whole thing equal to 0. So I've now got x squared plus mx minus 4 all squared. I would expand this out. I would locate the coefficients. I'll quickly do it for you. So let's go ahead. We've got an x squared plus, this is going to be m squared x squared plus 16 minus 8mx. And I've got a minus 4 here. Minus 4 is 0. So I would now go ahead. 16 minus 4 is going to be plus 12. And I've got an x squared and an m squared x squared minus 8mx plus 12 is 0. Here are my coefficients now. My coefficients of x squared is going to be 1 plus m squared. So if I factorize this out, this times this is this, and this times this is this. I've got a negative, what have I got? I have to put plus. Hang on 1 second. Plus x, here it is. So my plus x, and I've got a negative 8m as my coefficient. There it is. And then I've got a plus 12, and everything equals 0. So my coefficient here, my a value is 1 plus m squared. My b value is going to be negative 8m. And my c value is going to be 12. And the whole point of this is, in order to reconcile that m value and find out what the values could possibly be that resulted in a gradient of a line which touched this circle at one point, all we would do is say b squared minus 4ac is equal to 0. And there's our b value. There's our c value. Here's our a value. We would substitute these in and then solve for m. And we would end up with that. So that's an example of when you would use this and make the discriminant equal to 0. And that's when we would use the discriminant equals 0.